When dealing with reactions in solution where the reaction is taking place between two compounds that are dissolved in something else, normally their quantities are expressed in concentrations rather than just moles. And the unit of concentration in chemistry is molarity, which is moles of solute, which is the thing being dissolved, over liters of solvent, the thing doing the dissolving. For example, salt water. Salt is the solute and water is the solvent. So if I wanted to calculate molarity of salt water, I'd find the moles of however much salt is in there and then divide it by the liter of waters, and that would be the molarity. So let me calculate a molarity real quick. It's very easy to do once it's seen. Suppose I have 11.5 grams of sodium hydroxide. In a 1.5 liter solution. What is the molarity? And molarity is abbreviated as a capital M. So molarity is moles of solute over liters of solvent. Liters of solvent is going to be 1.5 in this case, but I need to convert 1.5 grams of NaOH to moles in order to calculate molarity. So I'll do that. 2.99 is sodium. O is 15.99. And hydrogen is 1.01. So tally these up. This is the molar mass of NaOH. Now I convert grams to moles. And this is equal to 0.288 moles. Now that I have the moles and I have the liters of solvent, I can calculate the molarity of NaOH. The molarity of NaOH would be moles of NaOH divided by the liters of solvent, or total solution, which is 1.5. And this is equal to 0.192 molar NaOH. So that's how to calculate molarity. It's very simple. It's just moles over liters. Now let me do a stoichiometry problem involving molarity. I want to, in this problem, calculate the number of chlorine ions in 1.75 liters of 1.0 times 10 to the minus third zinc chloride. And this is what the reaction looks like. This becomes aqueous zinc ions. And aqueous chlorine ions. So what this problem wants to know is, what is the total amount of chlorine ions if I dissolve 1.0 times 10 to the minus third molar zinc chloride into a 1.75 liter solution. Zinc chloride dissociates into one zinc ion and two chlorine ions. So right away I know that this is going to be double. The concentration of chlorine ions is going to be double the concentration of zinc chloride. It's just like a regular mole to mole ratio. Instead of moles though, it's concentrations. It works the same way though. So I need to figure out the total amount of chlorine ions. In order to do that, I need to figure out what the concentration of the chlorine ions is first, and then I can convert that into moles. So I have a concentration, oh I forgot to put the M. I have a 1.0 times 10 to the minus 3 concentration of zinc chloride. When this dissociates, it becomes a concentration of zinc ions and a concentration of chlorine ions. When this dissociates, the concentration of zinc chloride is going to be equal to the concentration of zinc. However, the concentration of chlorine is going to be twice the concentration of zinc chloride, just like a mole to mole ratio problem. So this is a mole to mole ratio problem, except it is in concentrations. So when I have 1 molar zinc chloride, it dissociates into 2 chlorine ions. So that means I'm going to have 2.0 times 10 to the minus third molar chlorine. Now that I know the concentration, I have to convert this to moles. I have liters here. If I have a concentration of 2 times 10 to the minus third moles per every liter, and I have 1.75 liters, I can figure out the total amount of moles. So I'm going to come down here and write this as 2.0 times 10 to the minus third moles of chlorine ions for every 1 liter. Now I'm going to multiply it by 1.75 liters. Liters cancel, which leaves me with just moles of chlorine. And this is equal to 3.5 times 10 to the minus third moles of chlorine.